that packet sniffing, right? So what is a packet? So for now you can assume that packet basically has the information that has to be sent from one computer to another. Okay, so for now just assume so. Okay, so there is some specific targeted meaning of this term packet, but for now, for convenience sake, think of it this way, that one computer in the network is sending some information, some data to another computer in the network. Now this packet basically contains part of the information that is sent. Okay, so the information in the form of messages is truncated into different parts. These different parts are put together as packets, and these packets basically are the ones that apart from the information that they carry, they also have few other information. So together, so these packets, like so what do they have, etc. You need to know. So that is where this packet sniffing basically, or network sniffing, as holistically you can think of, like what are the streams of packets that are flowing across. You really need to understand what is inside. So that is what will be helpful through packet sniffing. Now, network sniffing, packet sniffing, etc. can be done in different ways. Unix or Unix or Linux already has certain inbuilt commands for doing part of the thing, but there are some inbuilt tools which can help in packet sniffing. So one such tool is called Wireshark. Wireshark is a very popular network sniffing tool which has a graphical interface to decode different protocols, and with the help of different filters, different protocols. I already told you what is the meaning of the protocol in the first class in the theory. So all of you know about what is protocol. So every protocol basically, basically executes in a certain way depending on what that protocol is supposed to do. So these network sniffing tools basically help you to understand what are these PDUs, the protocol data units that are passing across from one computer to another. And so wherever you install the Wireshark, this packet sniffing tool, the network sniffing tool, there actually you can really understand, you can decode what are the protocols that are coming in, what are the packets that are coming in, what are the packets that are going out, right? And so depending on the protocol that is involved, you will be able to see like which protocol this packet belongs to, etc. So like that. So whenever I say packet, basically, as I told you, so this is, I am using it in a very loose way, but basically, so what you are doing is you are trying to understand the protocols that are getting executed, the protocol data units that are passing through, and so on. So I said packets, but you can now generalize to all the different protocols. Okay. Now, yeah, so how do you do it, right? So we'll try to understand it with the help of some I will give you a demo of how this Wireshark tool basically works. Okay, so before that, let me tell you that in Linux you already have uh, something called TCP dump command. I do not know how many of you have used TCP dump. Can you tell, like, if anybody has used TCP dump command before? Anyone? No one. So this is very commonly used actually. This is a very commonly used command, which TCP dump, which basically helps you to get an understanding of the packets that are being captured, right? Capturing the packets and understanding the contents basically, right? So TCP dump is a command line interface, whereas you can think of Wireshark to be like TCP dump with some more features, including having a graphical interface. So this Wireshark basically can help in capturing the data packets and then analyzing graphically what is inside. So it provides a graphical user interface. Okay, so TCP dump is somewhat kind of like a smaller version, and Wireshark has many more features. You can do a lot of different types of analysis with Wireshark, which I am going to talk about shortly. So, so let us try to understand. Let us try to understand how this Wireshark works. I will give you a demo, but before the demo, let me show you some of the important interfaces of Wireshark. So first of all, so before this, all these all the lab assignments, including use of Wireshark, etc., everything mandatorily has to be done in Linux, preferably Ubuntu. Okay, so all of you, all students, if you are wherever you are working from, make sure that you have access to Linux, preferably Ubuntu. Okay, so is there anyone who doesn't have access to Linux right now? This is a basic requirement. Anyone? So everybody has access to Linux, right? So this is the basic assumption that I have made, that everybody should be having access to Linux. In case you do not have, just make sure that some way or the other you get access to it. Maybe you can partition your hard drive into two and then install Linux in one of these partitions. Okay, so that there is dual boot in your laptop or desktop, whatever you have. So everything that we do in this lab, once again, will be done in Linux. So you have to install Wireshark in Linux, and after I will tell you how to install. So how to install means what is the command for installing, and then once you have installed Wireshark, you have to invoke Wireshark. So the moment you invoke Wireshark, you will get a screen like this. So top left, so you will get a screen like this. Okay, so I will also tell you how to invoke Wireshark through your command line. So this interface, basically, through this interface you can get you can try to understand what sort of traffic is flowing from and to the computer where you have installed Wireshark. Okay, so let us say on your laptop or my laptop at present, whatever I am using, so if I have if I invoke Wireshark, basically, so I would be able to understand that what all packets are coming through and what all packets are going out. And I say packets, but PDUs in general, the contents of all the PDUs, the protocols that are involved. Okay, so now every device in a network has certain interfaces, which we call as the network card or network interface card. So some interfaces are there. For example, my laptop, it has Wi-Fi card, so it has the Wi-Fi interface. It has an Ethernet card, so it has an Ethernet interface, and like that, actually, different machines have different interfaces. So depending on what all networks it can support. So the moment you invoke this thing, you will be able to get the list of interfaces that are so automatically the Wireshark is going to detect those. So you need to double click on the name of the network interface that you want to analyze. That means that if I want to analyze that on my Wi-Fi, what all PDUs are coming, what all PDUs are going out, etc. Okay, what all packets are coming, what all packets are going out. If we want to do that, so I would be double clicking on this Wi-Fi interface, to the Wi-Fi interface, whatever is happening. So I should double click on that. Okay, So the moment you double click, you will be able to see a screen like this. You'll be able to see a screen like this. And on this particular screen, okay, so you will be able to, you will be able to get continuously the packets, the list of the packets that are coming in and going out from your machine, right? So it starts from, so it's the first column will be apart from the, so the first one is number, right? So number means packet number. The next one is the time, at what time instance, okay. Third is basically the source node, okay. Fourth is the destination node. So these are basically the hexadecimal values, right? So so the source MAC address, the destination MAC address, okay, and the protocol, that particular PDU belongs to, so which part of which protocol it belongs to, the length of the PDU, and some other information, for example, some additional information like, whether it belongs to application layer or whatever it is. So let us say that after some time you stop, okay, the packets from coming into this particular tool. So by doing so, by clicking a particular mouse button, you'll be able to stop. So once you have stopped, you will be able to see all the packets that have come in or that have gone out, all these list of packets. And you need to do it pretty fast, because within a very short duration of time, within few seconds, basically, you will find that you have received thousands of packets. Okay, it's very fast, right? So it will become unmanageable if you include too many packets to be analyzed. Of course, so whatever you need, you can do, but just for the sake of playing around, you just have to, you just need to, capture only those packets that you need. So after you have stopped that, and you need to now understand that what is there inside each packet, what is there inside each packet. So let us say that we need to analyze packet number 2032, okay, which came in the time instant this one, okay. So this is the time instant 36.951504, okay. So the moment you start, remember one thing, the moment you start this packet sniffing tool, the time counter starts from 0, okay. So it starts from 0, and so this is, let us say, after 36 seconds, 36.951504 seconds, okay, this packet was received. Now what is the source address from where it came, the destination address, the protocol to which it belongs to, the length of the packet, okay, and so on. So now you have double clicked on this. So if you double click, you will be able to see a couple of different things, okay. So the frame 2032, okay, 74 bytes on where, 74 bytes captured on interface 0 Ethernet port to source, like that, so you will be able to see a lot of different information, like how this packet, how so you will be able to see the stack information. You see that frame, this is basically, frame, Ethernet, etc., IPv version that is that it belongs to, then the TCP protocol, so which is used, the source port of it, the destination port, like that, so like that, so you will be able to get a lot of information, the stack information, in fact, right, if you double click on any of these different packets, okay. Now the contents of these packets, basically, you can even go further down and you will be able to see the contents, right. So this is basically in the hexadecimal form on the left hand side, and this is basically in the ASCII form, right. So so then basically, this is basically showing you how to stop the packet capturing. So there is a button like this which you will have to press in order to stop the capturing of the packets. Now there is some color coding that is used in order to understand the type of traffic. So if it is TCP traffic, it is going to be colored light purple. If it is UDP traffic, light blue, and the black basically identifies packets with errors. Okay. So these are some coloring rules that are used. So there are different types of filters, okay, that are used. So I already told you about it. So these are called the display filters. So if you click on the display filter, okay, so this what you get is the name and the filter, corresponding filter, okay, that is used. Okay. Now for inspection, already I told you, how to inspect a particular packet. So these things and so on. So this is basically, so let me tell you. So this is basically, how this Wireshark works. So I will give you a short demo quickly, and at that time, you will be able to understand better, how things are working. Let me now tell you also about something called client server programming. Okay, so client server paradigm. So you see that in the theory, I already told you that you have two different computers which may be directly connected, which may not be directly connected, but there is something that I did not tell you, that each of these devices in the network follow something called the this different layers basically, right? So there are different layers. So the way things work in a TCP/IP network or the internet is that every every device in the network basically runs certain stack. Okay, so this stack basically has certain layers. So this interaction between the different devices basically is peer to peer, which means that the layers, the layer of a particular layer of one device will be talking to the same layer of another device. Okay, so this is basically how this layered structure works. So there are in TCP/IP you can think of like 5 layers are there. In OSI model there are 7 layers. So I will talk about these layers later on in detail in the theory class. For now, just assume that every computer that is connected to the network will be running different protocols belonging to these different layers. So if we are talking about the internet per se, every device has certain layers, maximum 5 layers are there. So these different protocols will be running on these different layers. So these 5 layers basically, so it starts from something called the physical layer. Then there is the data link layer, network layer, and transport layer and application layer. More or less, it is like this. Actually, there are some specific names that are there, which when we cover that part during the theory, at that time I will tell you. For now, it is safe to assume that there are these different layers, and between the layers, basically, this communication takes place. Now, this communication takes place. Okay. Now, so there are different types of communication that can happen. One of which is called the client server type communication, right? So in the client server, basically, again, as the name suggests, there is some server which serves different clients. So the client basically sends certain requests to the server, and the server basically processes the request and sends back the response to the client. Okay. So the software, basically this client software, initiates a connection and sends the requests, initiates a connection and sends the requests, whereas the server software listens for these connections and processes the requests. So client is for sending the requests, for initiating the connection, sending the requests, whereas server is for listening for these connections and for processing the requests. So we have client and the server. Okay. Now let us say that today in the morning I was showing you, I was drawing, how the internet looks like, right? So I have shown you that there could be multiple local area network. Let us say we are talking about one local area network of an organization, another local area network of another organization, so like that. So this is the internet. You have these different private lands belonging to these different institutions, right? And you have a server belonging to one LAN, and you have client devices belonging to other LANs. Okay. So client means what? Client means that, just the dictionary meaning of this term, right? So client means it's kind of a software which requests something, and server is the one which will process the request. Okay. So I think this is something that you already know by now, but this client server paradigm is a very popular paradigm that is used in the internet. There is also something called peer-to-peer, which I will tell a little later. So one computer from one local area network, sending some request to another computer, another server, basically belonging to another local area network. This is one typical possibility. It could be possible like, the server belongs to the same LAN. That is also possible. But this is some typical scenario that you encounter in real life, right? So for example, there is some server in the Google data center, right? There is some server in the Google data center, and when you are trying to connect to that Google server, you are doing it from your IIT Kharagpur campus LAN, but the server is located somewhere else. Maybe the server is located in a data center in San Francisco. You understand? So this is how things work. Now, how this connection will be established? What are the protocols that will be required in order for the communication to take place, etc.? This is something that you are going to learn during the rest of the semester in the theory. You understand? So once again, just as a recap of what I talked about in the morning, that in every local area network there is a switch, right? So the switch basically knows like which computer, if any packet that comes to it, okay, so it knows like how to relay the packet to the computer to which it is destined. However, if the destination node is not within this particular LAN, this is where this router can help. This router basically can send the information to another next hop router, that router to another router, and so on. The process continues until the data goes to the server. Okay. Now you see that there is a direct communication from the client to the server like this, right? So from this client to this server, this client to this server. Is it clear? So this is what it looks like, the overall picture. So in this semester, basically in the lab, what we are going to do is how to make this client server communication established, and how you can send the data from the client to be processed by the server, and then the results of the processing to be returned back to the client. So this is what you are going to program today and in the rest of the semester. So so everybody understands the basic paradigm in how things work. So so the packet that you send, okay, from the client, the message that you send from the client, it is going to pass through switches, routers, and so on and so forth until it goes to the server, right, belonging to another local area network, and then the server will do some processing and send the response back. Okay. Now let us try to make things happen. So before we do, another contemporary paradigm of communication is called peer-to-peer. So earlier, as you remember, it was from a client to a server. Now it is, you see, between two different clients, like this direct communication between two different clients. So in a peer-to-peer network, you have this hardware and software that can enable the communication between two different computers without the need for a server. So there is no centralized server for processing the peer-to-peer communication requests, right? So there is no involvement of the servers. So the peers basically directly interact with one another without the requirement of a central server. This is how peer-to-peer communication takes place. So you see peer-to-peer, no server, peer-to-peer. Earlier it was what? Peer, client to server. So that's the paradigm difference between these two. Now let us try to understand that how you are going to make this client server program work. So for this you need to understand something called sockets. So what is a socket? Socket is very similar to the electrical sockets. A socket in a network is very similar to the electrical sockets. So by the way, these terms, sockets, etc., again in theory, again we will encounter these and we will try to understand sockets in much more detail. Not now. After couple of weeks, basically we will come to the concept of sockets. But for now, we will simply stick to whatever I am telling you over here. So in a simplified form, you can think of a socket in computer networks to be an endpoint of a two-way communication between two programs running on the network. So you have two different hosts. Let us say you have host 1, you have host 2. And I told you that each of these hosts, they are divided into different layers. So let us assume for now that these are some of these different protocols that run in each of these different layers. So these protocols, they constitute the different software. So what we have peer, that means layer, one layer, communicating with another layer, one layer with another layer, one layer with another layer here. So for this, basically you have these different protocols that will help in the communication between the peers belonging to the same layer of the two different devices. So what is this socket? Every computer connected to the network will have this socket. It's the endpoint to which the wire or the network interface is going to be connected. Okay, it's similar to the electrical sockets. Everybody knows this term, the electrical sockets, right? The plugs where you plug in things, right? The electrical plugs. So here also you have computer sockets to which you can plug in, conceptually you can plug in something through which the the messages are going to pass through. So it's an endpoint of a two-way communication between two programs running on the network. So once you have created two different sockets, one on the host, the other one on another host or a server, then you can have socket to socket communication, right? So this socket to socket communication, so what you will have is interprocess. So every application, so you can think of an application to be the execution of several processes, right? One or more processes. So every process, so there will be one process of one application running on a particular host, communicating with another process of another application running on another host. So inter-process communication takes place. Inter-process communication. Now, how it is going to happen? Inter-process communication through sockets, how it is going to happen? So you need to really create sockets. So you can have broadly three types of sockets You can have three types of sockets in the internet. One of these sockets is called the stream sockets. The other one is called the datagram sockets, and third type is called the raw sockets. So when you do programs, you have to write the type of socket that you are creating. If you are creating a stream-like socket, which is also called a TCP socket, so it is going to be identified as sock_stream. If it is a datagram socket, it is going to be identified as sock_dgram. And there is a third type which is called the raw sockets, which is referred to as sock_raw. So mostly we'll be dealing with either stream sockets or datagram sockets. So so for now, don't worry about the raw sockets. Raw sockets have some specialized requirements. So for some specialized purpose, for example, it works for ICMP, IP, etc. So we'll be mostly we'll be focusing on the stream packets and datagram packets. The stream sockets and the datagram sockets for most of the code that we do over here as part of this course. So let us try to understand that how two applications belonging to two different hosts or two different computers, how these applications can talk to one another. So it might so happen that so how these two applications basically talk to one another. So for this you need to take help of the sockets. So let us try to understand this socket to socket communication. So ultimately, when you are talking about applications, two different applications talking to each other, essentially you are talking about at the process level, you are talking about process to process communication, inter-process communication. So this inter-process communication will be provided by the operating system that allows the processes to communicate with each other. Okay. Now these processes are going to communicate in the network over a pair of sockets, one belonging to each process, one not belonging to, one corresponding to each process. So you have a client process, you have a server process. So the client sends a request, the server executes it, sends a response back, and the client basically gets a response that is sent by the server. So you have, if you think of one computer, the client computer, the communication is done through its socket to the socket of the server. So the two sockets, one belonging to this particular client, one belonging to the other belonging to the server, these two sockets basically will help in the formation of the establishment of a logical connection between them. So this logical connection is going to be established, and the client process will send a request, the server process will process the request, will receive the request, process it, and send a response back. So this is what we have to write the programs for, how we can make these things happen, how we can create the socket, how we can send the requests, how we can get the response back and process the and display the response or whatever. So between the application layer, client process, and the application layer, server process. Okay, let us try to understand it. So we are interested in this socket because ultimately it is this socket which can help in this communication to be done. So how do you create the socket? What is inside the socket? Let us try to understand what is inside. So every socket is basically, every socket has some address, right? It is called the socket address. The socket address basically is comprised of two parts. One is the IP address, the other one is the port number. 32-bit IP address with 16-bit port number. So that together forms the socket address. IP address with port number is the socket address. So this is this socket, nothing big. Okay. Now, so gradually let us try to understand that how do we do this programming. Let us try to understand that how to do this programming. Okay, so so there are these header files, right? There are these header files that you will be using in your program. So remember that the type of program that you are going to write, these socket programs, are essentially C programs. These are C programs. So in order to write these C programs, whatever you did in your PDS, first year PDS, for example, exactly whatever you did, you will be doing those over here as well. But the C program that you will be writing over here will be a little bit more advanced, will be a little bit more specialized. Understood? So let us try to understand. Okay. So first of all, as is done in any C program, you have to include certain header files, right? So some specific header files that are required in socket programs are listed over here. These are the specific types of header files that are used in socket programs, socket C programs. So each of these header files basically has certain purpose. So for example, this net inet, this one basically contains the definitions of the internet protocol family such as IPv4 or IPv6. Okay. This ARPA name ACR contains the definitions used to support the construction of queries and the inspection of answers received from a domain name server available in a network. NetDB contains the definitions for network database operations. And like this, actually, you have these different other header files that will be required for including in your socket programs. Okay. So one of these is basically the socket.h. So this basically is a very important one because it contains the definitions of the socket addresses. And another one that you will also find quite handy is the types.h, which basically contains the definitions of the various data types. So what are these data types that are supported? That we will have a look very shortly. So like this, actually, these are some of these different header files and their corresponding descriptions that are given over here. Let us try to understand now that we know the header files, the different libraries that will be involved. Let us try to understand that how do you write a very small client server program. So we will gradually build a very small client server program. Okay. And so let us see how we can do it. So first let us try to understand that how this client server program is going to work. Okay. So you see that whenever we are talking about a server in the client server, the server is responsible for making all these processing of the requests that come from the client. So there might be one or more clients, not necessarily just one client, one or more clients. So every client sends some requests to the server. So you can process all the requests that are coming to the server sequentially, or you can process them in parallel. So both of these are possible. So let us first try to understand that sequentially how it is going to happen. But before that, let us try to understand how the server side program is going to work, and then we will understand that how the client side program is going to work. So some of these different system calls or the function calls that will be required on the server side is, first you have to create the socket. You have to first create the socket. Okay, you have to first create the socket on the server side. You also need to create a similar kind of socket on the client side. So let us first look into the socket on the server side. So first you have to create the socket, you get the socket file descriptor, okay, and then you have to bind. You have to bind the function, okay, with the particular IP and port. The socket binding basically, you will have to do. So this bind is a function, a system call that is used to bind the function with the particular IP and port. Okay. Then basically, once that is done, the server basically goes to the listen mode. So listen means like, it will hear, it is like listening, right? So whether any request is coming to it or not. So it will be in the listen mode. So it will try to hear whether there is any connection that is coming to it or not. And then comes the accept. Okay, so accept basically no, so before that, so before the accept, let us try to understand. So we have created the socket on the server side, we have created the socket on the client side, then this bind operation is done, the server goes to the listen state, then basically the client executes the connect function. So the client function, the connect function is then called on the client with 3 arguments, namely the socket descriptor, the remote server address, and the length of the address data structure. So this is done. So connect, and then it sends a request, connection request, right? Then the server basically has to accept that connection request. The server has to accept, and it might so happen that more than one request come from multiple clients. So one by one, if it is something called iterative server, one by one it is going to process these requests coming from multiple clients. Okay. So then the server, what it will do is it will extract a connection on the buffer of the pending connections of the system. It will accept one of them. It will extract the connection on the buffer. Buffer means that this buffer basically has all the different connection requests that are coming to it. Okay, and then a send is used to send the message either from the client to the server or vice versa, and then the receive function is used to receive the messages at both the ends. And finally there is a close. Okay, so send, receive, and then close the connection. Close the connection means that you are terminating this connection. Okay, so let us try to understand this process through the code, right? So we have to understand. So what I'm going to show you now is some code snippets, some functions that will be helpful for performing these different functions at the client side as well as at the server side. So as we have seen before that we need to create the socket on the server side, we need to create the socket on the client side. So there is a socket function which is used to create a new socket descriptor. So as you all know that in Linux or in Unix, everything is a file, right? So basically, every operation is done between files, right? So here also, in the same way as in regular C programs, in file-based C programs, there is a descriptor. Here also you have a socket descriptor, right? So this socket function will be used to create a new socket descriptor. A socket descriptor will be created, and this socket function will take 3 arguments: the address family of the socket to be created. There are different address families. So the address family, the type of the socket to be created, and the protocol to be used with the socket. So like this: int socket, int domain, int type, int protocol. So these are the, in order to use this particular inbuilt function, the system call, basically you need to include these 2 headers. So what are these address family, right? So the first one is the address family. So there are different address families that are supported. So we will be typically using this AF INET address family. Mostly we'll be using it for IPv4 addresses. If it is IPv6 addresses, there is this IP INET 6 address family. So like this, actually there are few others which are also there, but because you will not be commonly using them, let us not initially try to complicate ourselves and go through them all. So just focus on the AF INET, which is going to be used as the address family. Then comes the bind call. This bind call basically binds the service function with a particular port and IP, right? So basically binding of the port and IP is required. Okay. So this bind function basically returns an integer. Okay. And there are two specific integer returns. If it is -1, then the binding operation has failed. If the return is a 0, then the binding is successful. And this is basically the syntax, the function, basically the function that will be used, the bind function, with the different components. These three, so the components are described over here. The first one is the sockfd, which is the socket file descriptor returned by the socket. So remember that this socket function basically returns the socket file descriptor, which is an integer, right? So it is this one. The sockfd is that particular integer socket file descriptor returned by the socket. Then there are two other fields. The next one, the second one, is basically a pointer. It is a pointer to a structure, and that structure is the socket address. The socket address is basically the socket address that contains the information about the address in the form of the parts port and IP address. So my address is basically the pointer to the structure, and that structure is the socket address structure. So sockfd is the file descriptor returned by the socket function. Then my address is basically the pointer to the structure socket address, and then the third one is basically this address length. So second one is the address, and third one is basically the address length, right? And this address length you can have by using the size of function. So size of then the entire structure, right? So struct sock address, if you write, right, this is the structure, right? So so if you give the size this thing, then it will give you the size of function. Size of function will give you the size of this particular structure, which basically is the integer address length. So these are the three different parts. One of you please confirm that you are with me. You are able to hear me?
Yes, sir.
Okay. Next comes the connect, right? So remember this thing. This is very important diagram, right? Socket, bind. Okay. Listen is there. Listen also I will tell you shortly. Then connect. Okay. So connect is basically used over here, right? So by the client. So let us try to understand this connect. So this connect call is basically the request that is sent by the client to the server for connection. Connect, connection. Okay. Connect is for connection. So who wants to establish the connection? The client wants to establish the connection with the server, which basically is listening continuously after it has been created and the address has been bound to it. So it is listening. Okay. So now this client function basically we can help in connecting the client with the server. So what are the different parts of this particular function? What are the three arguments over here that is taken by the function? One is the sockfd, the same file descriptor, which is returned by, which is an integer that is returned by the socket function. Then you have the server address, which is a pointer to the structure socket address. So server address, you see over here it is server address. So it gives the connection to the server, right? So it has to give the server address. The client has to give the address of the server, then only it can connect to the server, right? And then the same stuff, old stuff, address length, which is basically the size of this structure, sorry, the structure sock address. So the three parts. Okay. So this listen basically is what I skipped earlier, and let me tell you, the server basically after binding etc., it has to listen before it can accept a connection. So this listen function basically helps to listen to the various connections that are coming from the network from the different clients. So if this listen is successful, then it returns a non-negative integer. If it is unsuccessful, it returns -1. So that is why the return type over here as well to this particular function, the return type is integer. So sockfd again is the socket file descriptor, and backlog. This is interesting. What is this backlog over here? So you see, I told you that the server is receiving different connection requests from the different clients. So it can be 1 client, 2 client, 3 clients. So everybody is trying to connect to the server. The server basically what it will do is that depending on the type of processing that it can do, it can either process all of them at once parallelly, not once, but all of them parallelly it can process, or conventionally it will process one after the other. So one after the other, that is sequential iterative. Okay. So which means that once the server is processing a request that is sent from a particular client, it is not going to take up the next request until it has completed the former. But the thing is that the different clients do not know that what the server is processing. So they are going to all send the different connection requests to it. The server, what it will do is it is going to create some buffer. It has a buffer, right? So in the buffer, it is going to store these connections that are coming in the form of a queue. And it is this queue, that is the length of this particular queue, that is referred to as the backlog, which is an integer value. So this particular backlog is basically representative of the number of connections that are allowed on that particular queue. So 3 connections, 4 connections, 10 connections, what is going to be allowed? That basically you have to implement as part of this particular argument of the listen function. Okay. So how many it is going to queue up? That is part of this backlog. Then what happens? So connection request is sent by the client to the server. The server has to accept, right? So this accept system call will select the particular connection from the waiting queue. One of them it is going to take up. So maybe the first one that has come, it will take up the first one. Okay, on success of the execution of this particular function, these system calls return a non-negative integer that is a file descriptor for the accepted socket of the client. And if there is an error, -1 is returned. So this one actually takes 3 different arguments over here, this accept function. The standard good old stuff sockfd, which is basically that file descriptor coming from the socket function, returned by the socket function. And then this one is basically this address, right? So address basically, this address is basically the pointer to sock address. Okay, so this one I will just check a little bit. So this is basically the pointer to the sock address, and address length is the local integer variable that should be set to size of this, exactly the same thing, right? So here this part I will just check a little later. Okay, now comes the send and receive. Now basically the connection has been established. Okay, now basically the client and the server, so they are going to use this send and receive functions for sending the messages. So the send function is used to transmit the message to the other socket. Upon successful completion, send returns the number of bytes that are sent, and if there is an error, -1 is going to be sent. Okay. So like before, again these are the different parameters that are taken by the send function. Okay, so please go through them, and similarly you have the receive function, which will be used to receive the messages of the other socket. And finally, once particular client has already completed the request and the server has returned the response, and let us say that they do not want to communicate further, then the connection has to be terminated. The connection request that was sent by the client will have to be terminated with the server, because that way any further read, write, etc. the socket will be prevented, and anyone attempting to read or write the socket on the remote end will receive an error. So it is very important to close the connection, to terminate the connection. So termination of the connection is very easy. You use the close function call the close function, and the parameter that is used is the sockFD, right? So sockFD will basically be used as the passing parameter to this close function. Okay. Now let us try to understand a little bit further. So create, bind, listen, accept. The process continues. Client side, create the socket and connect the newly created client socket to the server. Broadly, this is what is done. So I was telling you that these requests are going to be sent to the server by one or more clients, and these requests are going to be buffered, are going to be queued up on the server end. So how you are going to do it, how the processing is going to be done by the server? Either the server is going to do a parallel processing, concurrent processing, concurrency is going to be there if it is a concurrent server. Otherwise, it is going to do some iterative processing if it is an iterative server. So today's assignment that we are going to give you will be based on this iterative server. So the first part of the question that we are going to give is on the iterative TCP server implementation, and the next one is going to be the iterative UDP server. Okay. So this TCP and UDP, right? So these are basically the transport layer protocols. These transport layer protocols basically help in this process to process communication with the help of these sockets, process to process communication. So the TCP or the UDP basically serves the layer above, which is called the application layer. So for now, many things will seem very confusing to you because you still do not know what are these different layers that are used. So you are hearing from me maybe for the first time the terms like, layering, then application layer, transport layer, TCP, UDP. You are listening for the first time, but don't worry too much about it. For now, if you simply understand that TCP and UDP are certain protocols that can help in establishing the communication process to process between the two end hosts or two end devices like a client and the server, that will be enough for you to proceed further. But so I would also suggest that in your leisure time you also try to understand a little bit further about what TCP does and what UDP does. Okay. For now, actually, even if you do not understand fully, it will be fine. But if you can try to get a little bit further insight, that will make your life a little easier. But the way we have in the course, the theory, basically when we will cover TCP and UDP, at that time several weeks will pass, right? So that is the reason actually I don't want to jump into it. Now the question that might arrive in your mind is that why I am not teaching TCP and UDP now. The reason is that if I have to explain TCP and UDP to you, there are many other precursors, many other basic concepts that I will have to cover, and that is what I am doing now in the theory. So it will take some time, but for now, as I said, the workaround for you is simply to get a little bit understanding yourselves about what TCP and UDP does, and just simply think of it as some protocols that can help in process to process communication. These processes that are running at the client end and the server end, these two protocols basically can help in the communication. So okay, now let us try to get into this iterative server. So again, as usual, the server, it will open the connection, right? It will open multiple passive TCP sockets, each bound to a particular port. Through this binding process, it will be bound to the particular port. Then the server basically keeps an array of function pointers to associate each socket with a service function, right? Then the server uses the select to determine which socket or port to service next. And when a connection is ready, the server calls accept to start handling a connection. Okay. So you see that more or less the same thing over here. You have one or more requests that are going to come, and iteratively the server is going to process one request at a time. So when one process is in one request is in processing, the other requests are going to be in the queue. Only after the first request has been processed, the second one will be taken up after that, and so on. So this is the iterative server. Now that is the TCP server, and you have the iterative server, sorry, UDP server. So UDP server client, this thing also works more or less the same way. So here this is done with the help of datagrams, right? So here you see that create a UDP socket, bind the socket to the server address, wait until the datagram packet arrives from the client, process the datagram packet and send a reply to the client. Go back to step 3. And same thing here also, create a UDP socket, send a message to the server, wait until the response from the server is received, process the reply and go back to step 2 if necessary, close the socket descriptor and exit. Okay. So first you will be doing the TCP, second you will be doing the UDP. Iterative UDP server is more or less the same kind of thing. The only thing that will be different between the TCP and the UDP servers, not only the primary thing that will be different will be the socket type. And what did I tell you? There are how many types of socket? 3 socket types, right? Do you remember? What are these 3 socket types? Here. The first type is sock stream. It is basically for the stream sockets. The second one is for the datagram sockets, sock datagram. So we will be using these 2. The first one you will be using, the stream sockets you will be using for the TCP server, and the second you will be using for implementing the UDP server, sock datagram. This is the primary difference. There are some small differences here and there which you will understand yourself. So let me show you a couple of other things. Okay. So I hope that my screen is still visible. Can you all see my screen?
Yes.
Can you see my this Windows Explorer, this particular screen?
Yes, sir.
So I will give you a couple of things. So I am going to give you this socket tutorial. Okay, this is something. It's a very short guide, which will be very handy for you for socket programming. This is a very popular guide. Okay, it is called the BGS guide, network programming. Okay, so BGS guide, this particular BGS guide is very helpful. So here, whatever I told you, you can get those things plus some additional information which can help you to crystallize your understanding beyond whatever I have said so far. And these particular system calls that I was telling you, all these system calls you will find over here, right? Sock, bind, connect, listen. So this is the this one and these structures, right? So this part 3 and 4 are very important for you for working on your assignments. Okay, and the rest of the stuff, okay, are okay. I mean, whenever you get time. So section 3 and section 4 are the most important ones for you to work on your assignment. Okay, more or less I have told you, but you know this thing. But if you once you get access to it, take your time to go through it as well, primarily focusing on these 2 particular sections. Okay, so what I'm going to do now is I am going to show you some sample codes. Okay, I'm going to show you some sample codes. I'm going to show you, so first I'm going to show you TCP client server, how the TCP client server programs work, and then similarly UDP client server. So we have 4 programs for the TCP implementation, TCP client server implementation. We have 2 programs, 2 files, 2 C files, TCP client.c and TCP server.c. And similarly for the UDP1, UDP client.c and UDP server.c. So what I will do is, each of these programs are pre-written for you. I'm going to share these with you. So most of the stuff that I have covered so far will be used. So this will be quite self-explanatory to you, plus this BGS guide, use them together to understand these programs. So once you have understood these programs, so this is the TCP client and this is the TCP server, TCP client, TCP server. Not too big programs, very easy to understand. Okay. The only thing is that, this pointer to structure, that kind of thing you have to recap, in case you have forgotten those, right? Typecasting and, couple of these, basically these are very simple C programs with some predefined system calls that are given to you, and make sure that you include these specific, header files that are required for, the socket programming, because these will be helpful for you. Otherwise, these function calls that you will be making, like socket, etc., these are not going to work. So these are like, standard things that you will have to include. Okay, not the stdlib, but the socket specific ones. Okay. Okay, now, and many of these things, what you will also have to do beyond this tutorial, this BGS guide, you will also have to do a little bit of, you have to learn actually. From now, you have to learn. You have to learn how to troubleshoot, right? So gradually, when you will go to your workplace, whenever you will be working in the company, at that time actually, this sort of troubleshooting will help. Like, for example, if you are getting a particular type of error, right, and you are not able to easily troubleshoot, if it is not a syntax one or whatever be it, so if you are not able to easily troubleshoot, there are a lot of help that are there in the internet. So what you can do is you can dump that error message and see, whether you can get some help on the internet, right? So this is the way actually, complex programs basically, you can troubleshoot easily. This is just a, tip that I have given you. You don't have to do exactly whatever I have said, but this is something that I find very useful. Many of these errors, debugging, etc., if you dump on the internet nowadays, internet is very resourceful. You will get a lot of help over there. So finally, the final part before I let you do your assignments. Acha. So assignment also, let me show you. Okay, let me show you the assignment now. I will share it with you on Moodle. This is the assignment. Okay, so assignment 1. So this is the assignment. The first part is basically to implement the iterative TCP server. Okay, so you can feel free to use the sample TCP server program that I have given you. Okay, but you also need to do a couple of other things. You need to execute a sequence of operations. So for example, the steps that are given over here will have to be implemented, right? So you will have to start, like, the server opens a TCP socket and waits for a request from the client. The client reads the name of the text file from the user as a command line argument. It then looks, so like this description is given over here. Okay. So if the file is found, then it does something. If the file is not found, then it does something else. The client then establishes a connection to the server. So all I'm telling you is that more or less it is like this code that the sample code that I have given you, TCP server and TCP client.c, more or less the same thing like this, but you have to make certain modifications on top of these things by following these instructions that are given. Where is it? That are given over here. Okay, you read yourself, you will be able to understand. Achha. Now, another thing is that another thing is that after you have done it, the part B is what? So the first one was TCP server. The next one is UDP server, iterative one. And I told you what is the meaning of iterative already. So the next one is basically just the. So there is a small difference actually between. So once you have done part A, part B is much easier. Okay. So you will have to explore, like, so what you will have to. So how you are going to submit the assignment, those instructions are also given. Okay. And the deadline is basically 1 week away. Okay. You don't have to submit today. So you have ample time, lot of time you have. Okay. So it is not like your PDS lab that on the same day you will have to hurry and you will have to submit. We have given you enough time, 1 week, explore, and find out, like, which all mistakes you are making. Try to learn from your mistakes. A lot of self-learning is also involved. Consult these different error messages that you are getting through the internet, whether other people have got them or not. So initially, actually, you will not find that kind of thing, because initially most of these stuff are very standard stuff. So it will be very easy for you to debug. But gradually down the semester, when you will write very complex, long programs, at that time, so this kind of tip that I have given you will be helpful to you. Next. So let us, yeah, let us try to now. Okay, let me quickly try to show you how things work. Okay, so now Konteo, can you open the terminal? So actually, what has happened is in my Linux, actually, this Teams, it is behaving in a very erratic way. So I will have to troubleshoot and figure out, where things are going wrong. In the meantime, I have requested one of the TAs basically to focus on the screen, and I'm going to give the narration, what all things will have to be done. So Konteo, can you focus your screen?
Yes, sir. So can you just unshare your screen from Teams so that I can...
Right.
So is my screen visible?
Yeah, it is visible to me. I hope that it is visible to others also.
So you can start now.
Yeah. Okay. So what we have to do, we have these codes. So can you just first open the code in the code folder? So these are the 4 files, right? So TCP client.c, TCP server.c, UDP client.c, and UDP server.c. Okay. So these are the 4 codes that we will run. Okay. So first, let us do one thing, that so these codes are already there. I am not explaining them further. So let us try to understand that, like, how you are going to make this execution. What did I tell you? I told you that you have to start the server first. The server has to go to the listen mode. Then you have to initiate the client. The client will send a request to the server. The server will do the processing, and then it will send the response back to the client. This is all we are going to do, right? And for that, we have these 2 C files that will have to do it. So TCP client.c and TCP server.c, right? Acha. Now let us try to understand a couple of things. So here we are doing the client and the server implementation on the same computer, right? We do not have separate computers. We have the same computer, right? So we will be using 2 terminals to emulate these 2, right? So client.c on one terminal, please open it on one terminal, client.c on one terminal, and the server.c on another terminal. So we'll be opening these 2 up on 2 different terminals. Okay. Now, so let us first try to compile one by one. Let us try to compile. So we will compile. Let us say the first one. Let us say the client program and a server program we will compile. Let us say, logically, let us go like this. It doesn't matter actually during the compile time whether you alter the sequence. It doesn't matter. So let us compile the server.c. So GCC will be using it's a GCC compiler. So GCC server TCP server.c Write TCP server.c, TCP server.c, then -o, yeah, so -o, then space, then TCP server. So TCP server, TCP server, PR. So TCP server is the name of that object file, right? That will be created. So yeah, so you see that the moment you do it, this TCP server.o has been generated in that same folder. Pontio, can you highlight on that TCP server.o? So that additional TCP server.o has been created. This is good old stuff. You must be knowing it from your C programming days, how to compile using GCC, right? So this .o file gets created. Likewise, let us do for the TCP client.c. So please do it for the TCP client.c, exactly the same thing. Here we will be changing from TCP server to TCP client. TCP client.c, and here change it to client. So another .o file is created. You see TCP client.o, two have been created. Okay, now I'm not doing it for the UDP server and UDP client. Exactly the same thing you will have to follow for the UDP. Now you see two .o files have been created. Now what do we have to do? We have to run them, right? We have to run. So for running, what do we do? Dot slash TCP server. So let us first start the server. On the other terminal, please start the client. ./TCP client. So you see that this is as per the program. So keep them cascaded, one after the other. You see that the server was started. So hello from then the client was started. So you see the first, if you look at the client's window, it is saying that hello message sent from the client. It goes to the server. Okay, goes to the server here. It goes to the server. Hello from client. In the server window, you see hello from client. Then after that processing, basically a hello message sent is appearing on the server side, and that is received at the client side. Hello message, hello from server. So this is a very basic implementation of client server programming. Now, one thing that is not a very good thing, not a very elegant thing about the code that we have given you as a sample is that the server, after processing the request, has abruptly ended. It has abruptly ended, right? That is why you can go to the command prompt immediately after that. So please highlight, Pontio, that part, that it has gone to the command, the dollar symbol you can see, right, in the server. Actually, it should not be happening. A server should go through like kind of an infinite loop. It should be always listening. It should not end. It should not terminate. It should be always listening. Okay, the port should be always open, not close the connection. But here actually, because it's a very simple kind of program, just to illustrate how to terminate connection, etc., we have given you. But remember that practically, the server has to be kind of like infinitely it should be listening, and it should be doing it until there is a necessity for closing the connection. So same thing you will have to do for the UDP client server as well. But another interesting thing we are going to do now. Okay, so please do not close, just keep these things in the so just put it open another terminal, So now you remember that today's class we started with Wireshark. Okay, so let us try to understand how we are going to use Wireshark. So for using Wireshark, basically, Wireshark is already installed on our computer. But if you have to install Wireshark, Pontio, please write that command, but don't execute it. Just write the command for installation after downloading. So sudo, as you know, is to do it as a super user, because if you have to do the installation of a particular software, right, then you will have to do it in the super user mode, right? So like the administrator mode in Windows. So here you have to do in the super user mode. So don't execute. So this is the command that you will have to use for installing Wireshark. Okay. So sudo apt-get install Wireshark. So all of you please write down sudo apt-get install Wireshark. Okay, everybody has done. Now let us go back, delete this line. Now let us say that we'll have to, we will have to start the Wireshark. It is already installed. So Kontyo, please start Wireshark. So sudo Wireshark is the command that you will be, sudo Wireshark, hit enter. Yeah. So, this is the interface that I was showing you in the PPT, right? So this interface, okay. Now, see that you have to use, so there are different display filters that are there, okay. So, and these are the different interfaces, so that could be used. So for example, so if you are connecting through, let us say Ethernet, you will get a corresponding interface. If you are using, if you are using Wi-Fi, which is not the case over here, I believe. So the Wi-Fi interface will show up, and another so Ethernet interface kind of over here. Actually the name changes between different systems, but over here the first one that is highlighted is the Ethernet interface. Okay, ENP, that one. Then 2 lines down is the loopback. So loopback is very important because for you will be using the loopback mostly for your assignments, right? So loopback because loopback interface is used for the same computer, right? So same computer, you are not sending to another computer. So this loopback interface will be used for the same computer. So few other, so all the interfaces will be detected over here. Okay. So let us start. So let us start. Which one we will do? Let us start with the first one. The first one. Let us try to explore this one first. So when you double click on that particular interface, you see the packet capturing will start very soon. You see all these packets. So Kontyo, go to the top. It has started from packet number 0, etc. All the way. If you drag it all the way to the top, you see that it has started from 0. Can you see very briefly? Yeah, it has started from 0. And the timing also you see 0 dot like that. The time and source and destination. Okay, the protocol that is also used, DNS protocol, like that. Source 10.0.2.15 probably is the IP of the computer that he is using. Destination probably is the destination computer, destination server or whatever, that is the IP address of that one, like that. So Kontyo, just stop the packet capture. Have you stopped?
Yes, sir, it stopped.
Okay, stopped. So double click on one of these packets, any one of these. Okay, now you see that you can get more descriptions about this particular packet, right? So further descriptions. So go to the last, drag it towards the second window. Yeah, so go towards the right hand side, right side. Let me see what is there. No, the middle frame, so go towards the right. So after the sequence number and acknowledgement, let me see what is there after that. Okay, so all these anyway, so all these different details you will be able to find over here, and at the bottom, as I told you, you have you have on the right hand side you have the ASCII characters, okay, and on the left hand side you have the hexadecimal characters, basically the hexadecimal numbers. Okay. So this is and now you have to explore. Actually many things are there, like on top there is statistics, analyze, so statistics you can click or analyze. See, there are a lot of things that you can do, right? So once you have collected the packets, etc., a lot of things you can do. So this is something that you will have to play around with. You will have to play around with, right? So I just showed you how to use this tool, but a lot of things could be done, and you simply have to play around with it. Now, let me do one thing. So earlier I have shown you how to run the TCP client and TCP server, right? So let us do it once again by keeping this open in the loopback mode. Okay, because the client and the server. Acha, one thing I forgot. So Konteo, can you open one terminal once again, another terminal, and type in ifconfig. So ifconfig, I think many of you already know. In case you do not know, will help you to get details of all the interfaces, the network interfaces on your system. So you see that the first interface where we did a double click was this, the Ethernet one, ENP whatever. This is the first one. So it says that you see link encapsulated Ethernet header. So it has given the header, then INET address, broadcast address, mask, like that. So all these details are given over here. The next one is the loopback address. LO is the loopback address. Okay, sorry, loopback interface. For this loopback interface, this is this loopback interface that I'm talking about right now. Okay, so now Konteo, please go over there and open in the loopback interface. Open that this thing, Wireshark, and then execute the same thing that we have done, the client server thing, once more. So we have now started in the loopback mode, right? Loopback interface we want to observe. We want to sniff the packets on the loopback interface. So you see that TCP client is executed, TCP server is executed, okay, like this. Now you go to that, so now you see, what do you see over here? See, in the packet sniffing tool, what do you see in the loopback interface? The source and the destination are the same, 127.0.0.1. Right? This is the standard loopback interface, basically IP address. Okay, so you see that. So along with your TCP client and server programs, you can also execute your this thing, this packet sniffer, Wireshark, to understand about what all things are happening. Which packet is going where, and so on. This might be helpful to you for a lot of debugging later on, debugging or understanding. So many times I cannot, for the next couple of labs probably you will not require it, but later on when the complexity will increase, at that time this packet sniffer will come very handy for you. Okay, so with this basically we'll stop over here, and so all of you please start working on the assignment. I'm going to share it with you. Actually on Moodle we'll be normally sharing, but for some technical reasons actually so Professor Gupta, he will do it sometime later today, but for now we are going to send you by email. Okay, we are going to send you maybe on Teams. We'll give it on Teams. Okay, this particular file will give it to you on Teams. Okay, so you start working on it. There will be some slight modification that might be done. Okay, so but that will be a very minor one. Some minor assumption will be written. So for now, just start working with whatever you have. Okay, but later on when you submit, make sure that you read the final one that is submitted on Moodle the final question paper that is submitted on Moodle. So we will let you start this thing. Okay, so Nidhi, now you can stop this recording thing, and now let us yeah.